Stellar populations. When we look at our own galaxy and at other spiral galaxies, it turns out that we can divide the stars into two main groups, and we call those groups stellar populations. The first person to discover these is this guy, Walter Baade, and he was actually looking at the Andromeda galaxy, because here you could see all of the stars more easily rather than looking within our own galaxy. And he noticed that the stars in the disk were very different from the stars in the bulge and in the halo. And so he came up with this idea of classifying these stars based on these differences in characteristics. So his first group are population 1 stars, so that's a Roman numeral 1 is what we're looking at there. These stars are found in the disk and in the spiral arms, because those are in the disk. So here's the disk of the galaxy, and here we see our sun falls into the category of a population 1 star. I have no idea how he came up with this idea of 1 versus 2, and which one he would call which, but the way that I remember our sun as being a population 1 star, we're number 1. So us, our solar system, our sun, is a population 1 star. The main characteristics of population 1 stars is that they are later generation stars. Now, star generations is always tricky. Later generations mean that they formed more recently. So these are the ones that came along after previous stars. So the heavy elements come from the stars that died before us. And so one of the things to remember, of course, in our own solar system, here on Earth, we have heavy elements. So if you remember, we're number 1, we have heavy elements, so population 1 stars have heavy elements. And we're relatively young, we're 4.5 billion years old. So that means we formed 4.5 billion years ago. The universe is about 14 billion years old, and the oldest stars are. So you can tell that we are much younger than the universe and much younger than the oldest stars. So we are more recent. So of course the other group are a population 2 stars, so make that a Roman numeral 2. And so these are the ones found not in the disk. And in particular, they're found in the central bulge, and they're found out here in the halo, because the globular clusters are in the halo. So the halo and the central bulge have a lot of things in common. And in many ways, the central bulge is kind of like one giant globular cluster. So it's not surprising that you're going to have similarities between what's found here in the bulge and what's found out here in the halo in the globular clusters. So these stars are first generation. So these are the oldest stars. These are roughly 14 billion years old. probably closer to 13, we'll say 14, 13 to 14 billion years old. And because they formed first, the only elements available were hydrogen and helium. So our stars in the central bulge, color doesn't show up well, stars in the central bulge, and then the globular clusters, stars out here in the halo. These are our first generation stars. These are the stars that are composed primarily of hydrogen and helium. So two very distinct populations. There is another distinguishing characteristic between the two, and that is their motion. Stars in the disk, the population 1 stars, move in nice, neat, orderly orbits around the central bulge. They all move in the same direction. Out in the halo, it's much more random. It still orbits the central bulge, but they go in lots of different possible paths. So you have different types of motion in population 1 stars versus population 2 stars. You have different compositions between the two, and you have different ages between the two.